In this video, you'll learn how to write the equations of ellipses and hyperbolas by completing the square. This first example is an ellipse, and we know that because we see the x squared term and the y squared term have the same sign. They're both positive, but you see how the coefficients are different. The x squared has a 16 and the y squared has a 25. If they were the same, then it would be a circle, but with them being different, we know it's an ellipse. Now the first thing we need to do is collect the x terms together and the y terms together. So we have 16x squared minus 160x. I can't leave a blank right now for completing the square because notice instead of having simply x squared, we have a 16x squared. To complete the square, a has to be 1. And so we have to do something else first before we can do that. Now for the y terms, we have positive 25 y squared plus 150y, and this constant, this positive 225, we're going to move it to the other side, change it to negative 225. So this is equal to negative 225. Now like what we talked about earlier, we said in order to complete the square, a has to be 1. So I'm going to factor out as 16. So 16x squared. Negative 160 divided by 16 is negative 10x. And here we'll leave a blank. Now for the y part, we need to factor out a 25. So 25 on the outside, so now we have y squared by itself. And 150 divided by 25 is 6. So 6y, and leave a blank. That's equal to negative 225. Now I will go ahead and complete the square for the x and for the y separately. For the x, our middle term is negative 10. Divide that by 2, get negative 5. And then square that, negative 5 times negative 5. You get positive 25 for the blank. Now for the y term, the middle term is positive 6. So step 1, take that 6 divided by 2 is a positive 3. And then square it. 3 times 3 is 9. Positive 9. So we'll write a plus 9 over here. And like what you have seen with the circles, whatever we do on one side of the equation, we have to do the same on the other. But be careful. For the red part, we did not add a 25 simply. We added a 25 which is multiplied to the 16 on the outside. So for this side, we have to add a 16 times 25. And for the y side, the blue part, we added a 9, which is multiplied to this 25 in front. So we have a 25 times 9. Now factoring the perfect squares, we have 16 times x minus 5 squared plus 25 times y plus 3 squared. And on the right side, 16 times 25 gives us 400. And 25 times 9 gives us positive 225, which will cancel out the negative 225 we already have there. So on the right side, it's all equal to 400. But remember, for ellipses and hyperbolas, we need the right side to be equal to 1. And so now we need to go ahead and divide everything by 400 so that we have a 1 on the right side. So 16 over 400, when we reduce that, it's the same as 1 over 25 because 400 divided by 16 is 25. So we have 25 on the bottom x minus 5 squared on the top. And here, 25 over 400, well, 400 divided by 25 is 16 on the bottom, 16, and then y plus 3 squared on the top. And that is the equation of the ellipse in standard form. For this example, we have an equation of a hyperbola. The reason why we know this is a hyperbola is we look at the x squared and the y squared terms. One is positive and one is negative. When you see one positive and one negative, right away you know that's a hyperbola. But hyperbolas, you know, it's either going to be x squared minus y squared or y squared minus x squared. And so whichever is positive goes first. So for this example, when we collect the terms, we're going to have the y terms come first because the y is positive. So we have 9y squared minus 72y. And for the x terms, we have a negative x squared minus 18x. And this 27 moves to the other side of the equal sign, becomes negative 27 equal negative 27. Now, remember to be able to complete the square, a has to be 1. So for the y, we need to pull out a 9. So we get y squared negative 72 divided by 9 is negative 8. Negative 8y. Leave a space for the completing of the square. And for the x part, we can't have a negative 1. We need to have a positive 1 in front of the x squared. So let's factor out a negative 1. So we can have x squared by itself. And negative 18 divided by negative 1 is positive 18. Leave a blank, equal to negative 27. And now we'll go ahead and do completing the square for the y and for the x separately. For the y, we look at the middle term, negative 8 divided by 2 is negative 4. Then square it for step 2. Negative 4 times negative 4 is positive 16. We will write that here, plus 16. And for the x part, the middle term is positive 18, which when we divide by 2, it gives us positive 9. And then square it, 9 times 9 is 81. So plus 81. And notice I forgot to put an x behind the 18. And now, to keep the equation equal, we have to do the same thing on the right side. So we have a 9 times a 16. So we have to go plus 9 times 16 on the right side. And for the blue part that we added, we have a negative 1 multiplied with an 81. So negative 1 multiplied with 81. Now we will factor the perfect squares. So we have 9 times y minus 4 squared minus 1 times x plus 9 squared. On the right side, this negative 27 plus 9 times 16 minus 1 times 81 gives us a grand total of 36. And now, because this is a hyperbola, we need to have the right side of the equation to be equal to 1. So we will divide 36 on both sides. 9 divided by 36, which is the same thing as 1 over 4. So we have y minus 4 squared over 4. And negative 1 over 36 is the same thing. Nothing changes. So 36 on the bottom. We have x plus 9 squared is equal to 1. And this is the equation of the hyperbola in standard form.